Ever wanted smooth and optimized column resizing even with 10,000s of rows in your React table? Combined with proper scrolling and sticky header? If you've been searching for a solution, this tutorial is about to save you hours of frustration. I'll be starting off from a simple React table built in next.js, utilizing shadcn UI and TanStack Table. This is what we've built in the previous tutorial. I will have a link down below in the description. Even if you have already made your own table, you should be able to follow along and implement the changes as well. First off, we're going to quickly clean up the project. Rename default header to header button. Delete the data table in page.tsx. Define the default size of the first and last column. This corresponds to the checkbox and the menu drop-down columns in our table. I will also remove the data table arguments as we will not need those either. Delete the global data from the data.ts file and instead export the create user function and use that directly in the data table React useState function. Don't worry, this does not recreate the data every time the component re-renders. Let's start by making sure our header resizes. In the useReactTable argument, set column resize mode to onChange. This makes it so that the table columns will resize as we move the resize bar around. Set column resize direction to left to right. We'll also want to enable column resizing for obvious reasons. Because we are going to be dealing with horizontal scrolling, we'll need to calculate the total table width and make sure that this is only recalculated whenever column size changes rather than on every render. This is why we use memo here. In fact, before we move forward, let's try running the project. You can see that with 10,000 rows, the page doesn't even want to load. Let's adjust the row data so it has 100 rows for now. Bump it up later once we've implemented optimizations. Okay, let's create the new header component that will have the ability to resize. We'll need to grab the resize handler from the header, which is provided by TanStack. The resize handler is an event handler that updates the states as well as handles the resize and re-rendering logic. Add the resize handler to the on mouse down and on touch start events inside the div that will act as the resize handle. Back in our table, create a table props variable to store the styling of the table. In order to keep the header sticky, we will be utilizing two tables instead of one. The first table will contain only the header and the other will contain only the body. Once we get to optimizing the table with virtualization, if both header and body is within the same table, this is not really a good way to make the header sticky. I found that this approach is the easiest and simplest way, but let me know in the comments if you figure out an even better way. Because of that, we'll need to make sure that the table header and the table body is wrapped inside a separate table. And then because we want a scroll bar to appear on the table header, wrap the table header table in a div and set overflow to hidden. Also specify the style prop for the div above that one and set the width to the table width, replacing the class name prop. This controls how large our table width is within the top level div, which will allow it to show the horizontal scroll bar when needed. Then, at the topmost div, replace the class name and add the style. Make sure to set overflow to auto as this is what will allow us to have horizontal scrolling. Looking at the web page now, you can see that there is a disconnect between the header and the body of the table, and we still cannot resize the header. That's because we need to replace the table header with the default header we created earlier. So let's do that. On top of that, let's go ahead and wrap the body table with a div so that the table height isn't determined by the amount of items inside it. Add the style prop to the div. Make sure that the overflow Y is set to auto and overflow X is hidden. We don't want this div to have horizontal scrolling, only vertical. Back on the web page, you can see that the header resizing works, but columns are not resizing with the header. Scrolling in the body table also works, but the scroll bar doesn't move. To fix the syncing issues between the header and the body, in the body table, add the table props, and then in the table body, remove all the class names and replace it with this width and position. You can also do this with Tailwind class names. We will need to create a new default cell component. The important element here is the width. Make sure that this is set to cell.column.getSize. This is a thing that will make sure that the cell inside each column is the same size as their respective header. Okay, now let's add the default cell component to the table row. Checking the page again, you can see that when I resize the header, the column cells are resizing correctly. Scrolling also works correctly. I'm going to make a small adjustment by putting the row selected text outside the table. You might notice that the resizing isn't completely smooth. It's a bit choppy, especially with larger row counts. Let's optimize this with TanStack Virtual package. In the simplest terms, what TanStack Virtual does is ensure React only renders the table rows currently visible in the viewport, rather than rendering every row all at once. This virtualization technique dramatically improves performance by reducing the DOM elements that need to be managed, giving you that smooth resizing experience even with thousands of rows. Implementing this is quite simple. Create two refs, one for the table containing the body and the row elements. The other will be for the outer container that encapsulates both our tables. These refs are needed for the virtualizer to determine the visible viewport area and calculate which rows should be rendered. Set up the virtualizer, giving it the row count, get scroll element, which will be the table container ref, estimated size, this is the best guess of each row's height. Overscan is the number of items to render above and below the visible area. If you increase this, there could possibly be more of a performance hit, but you won't see as much rows popping in. Create a virtual rows variable that we'll be using later in the table. Hook up the outer container ref to the topmost div element, and do the same thing with the table container ref and add that to the div that encapsulates the body table. In the table body, set the style height. Replace the table getRow model with virtualized row, making sure that the key in the table row is set to virtual item key. Now, if you try resizing the column, it's so much smoother. Let's try adjusting the row data so we have 10,000 rows. As you can see, it's still just as smooth. Congratulations! You just built a table with performant column resizing feature. Next, you are probably thinking, wow, this virtualization trick would be great for infinite scrolling. Well, why do you think I created this tutorial first? That's going to be one of the upcoming videos, so make sure to smash that like and subscribe button if you don't want to miss out. Thanks for watching, and I'll see you in the next one.